Welcome to Sundar's lecture. This is lecture number 5, and in this lecture we are going to start a new topic, that is Boolean Algebra. See what all the topics we have seen in the previous class. See, we have started with the conversion of decimal to any radix, and we have seen the procedure. The procedure is same, and we have done for all the number systems that has been converted from decimal, right? So this is the procedure that has two different procedures, the one for integer and one for fraction. So for integer it is successive division method, and for fraction it will be successive multiplication method. That is what we have seen in the previous class, and we have also concluded any radix to decimal. That was already we have discussed this one particular procedure in the first lecture, right? So in this class we are going to start with the Boolean algebra, right? So what is Boolean algebra and why it is coming? So that is what we are going to see. This is introduction. This is developed by English mathematician George Boole in between 1815 to 1864, right? It was so long time, and it is described as an algebra of logic or an algebra of two values. That means true or false. Either it will be 1 or 0. That is what they have given you here. The term logic means a statement having binary decisions. What is binary? Either it will be 0 or it will be 1, right? So it will be true or yes, or it can be false or no. So only two conditions, either 1 or 0, true or false, yes or no, right? So what are the Boolean algebra's applications? It is used to perform logical operation in digital computers. So if you are going for any computers, then it is going to perform in digital circuits, right? We are going to design the digital circuits in the upcoming classes, so I will explain you a bit later. In digital computers, true represents ones, that is high voltage, and then false represents 0, that is low voltage. And logical operations are performed by the logic operators. So those logic operators, we are going to see some gates, and also we are going to see the variables of Boolean algebra, and there are so many laws are available, and everything we are going to see the basics of Boolean algebra today, and we are going to implement those kind of Boolean algebras with the gates in the future classes, right? So the fundamental logic operators, what are all three different fundamental logic operators are there? One is AND, second one is OR, and third one is NOT, right? So AND, it is conjunction, we generally call it as conjunction, and OR we are generally call it as disjunction, and then NOT we generally call it as negation or complement values, right? So the next one, the AND operation. What is AND operation? See, AND operation, it is denoted by this one, like dot. We generally call it as dot operator. This is a dot operator. So what this dot operator will do? It is a multiplication. It is a multiplication operation. Multiplication operation, right? So we will see some example. For example, if you have any two variables, so x and y, x and then y, there are two variables. Let us assume there are two variables, and if there are two variables, then the operator will have only either a 0 or 1, so like it is a binary values, right? So if you have two variables, then how many combinations will be there? 2 power n is equal to, here n is 2, so n is 2, so 2 power 2 is equal to how many combinations? It will be 4. That's all. So what you do, so for x and then for I will take a new color. See, for x and then y, so if there are 4 number of combinations, what you do? 0 0 0 1, we have discussed this, we have already discussed this. It is 1 0 and then 1 1. And what this AND operator will do now? What this AND operator will do? It will do x dot y. That's all. X dot y, then it it is going to multiply. It is going to multiply. So 0 multiplication of 0, it will be 0. 0 multiplication of 1, it will be 1. 1 multiplication, sorry, it will be 0. 1 multiplication of 0, again it will be 0. 1 multiplication of 1 will give you 1. That's all. So this is the operator. This is the AND operator. Multiplication will be done by this AND operator. And the next one, second one, that is what we have seen, these kind of operators. And the next one will be OR operation. OR operation. So what OR operation will do? So it is generally denoted by, it is denoted by plus symbol, like this, plus. This is the OR operator, and this will do like addition, not exactly addition. No, you cannot say that this is an addition, but anyway, to understand things, this will do an addition operation. Let us we consider the same thing. X and Y variables are there. These two variables are there. Then what it will do? So for example, same thing, X, and then you have Y. So it will be 0 0 0 1, and then this will be 1 0, this will be 1 1, and this OR operator, it will be like this, X plus Y, that's all. So if you add these two, what you will get? It is 0. If you add these two, you will get 1. If you add these two, you will get 1. See here, if you add these two, you should not put 2 here, because this is a binary operation. So 1 plus 1 will be also 1 here. 1 plus 1 will be also 1 here, right? So it is not like 10 also. It is not like 10. So you try to understand, it is not like that. You cannot put 1 plus 1. So it is 1 plus 1, we have to put 10. No, it is not like that. It is 1 here. This is a operation, that's all, right? So if both inputs are high, then the output will be Y if OR operator performs. And the both inputs are high, then only the output will be high, then that performance will be done by the dot operator, like that. So it is like an understanding, right? So the next one, it is a not operator. So these three are the very important operators, right? So not, it is denoted by, like it is bar like this, or generally they will put like this, apostrophe comma, like I will explain you, right? So these two symbols can be identified as the performance of a not operator. For example, see, not operator will not have any two different variables. So for a single variable, we can go for the not operator. For example, you have a x as a variable, See, if x is there, if there is only one x, so it is 2 power 1, is equal to 2. N is equal to what here? Single variable. N is equal to 1 here. So this will be 0 and then 1. Either 2 can be done, because only 2 combinations will come down. And we generally put this not operation like x bar, or we generally put like x dash. Both are same. Then what not operator will do? It will complement. So complement the input. Maybe you can write like it is a complement operation. Like what OR and AND have done. See, AND performing multiplication, or performing addition. Like that, this not will perform a complement operation. Like if this is 0, then it makes to 1. If this is 1, then it makes to 0. Complement, right? So this is the 3 different operators we have in Boolean algebra. These basic operators, right? So what we will do now? We will go for truth tables. What truth table exactly means, that we will see now. See, this is truth table. See what truth table means. truth table is a table that contains all possible values of logical variables or statement in a Boolean expression. So it contains the what a performance has to be done by the particular circuit or the particular application. So number of possible combinations, we know this is actually not 2n, it is 2 power n, where n is the number of variables used in the Boolean expressions, right? So the for example, we will straight away go for an example there so that you can easily understand. See, the truth table for xy plus z is as follows. See, how many variables are there? 1, 2, 3 variables are there. Try to understand. You have 3 different variables. So n is equal to 3 here. N is equal to 3. So how many number of combinations will come? So 2 power n, which is equal to now, that means this gives 2 power 3 is equal to 8 number of combinations will come, because there are 3 different variables are available. That is very important. You have to be very careful while writing the number of combinations. So it will be x, y, z. So how many combinations will be there? So there will be 8 different combinations will be there. So it will be 0, 0, 0, 0, 1, 1, 1, 1. So 8 combinations. Again, this will be 0, 0, 1, 1, 0, 0, 1, 1. And then this will be 0, 1, 0, 1, 0, 1, 0, 1. Try to understand. These are all very important, right? So now what you have to do, you have to take this now, x, y, x. If there is nothing here, then you have to understand this is x dot y, x dot y. And then if you know this one, you can add with this, so you will get x dot y plus ez, x dot y plus ez. So you can do this one. For example, what is x dot y? You have to multiply these two. You multiply these two, you will get what? 0. Multiply these two, again you will get 0. Multiply these two, again you will get 0. Multiply these two, you will get 0. Multiply these two, again what? You will get 0. Multiply these two, you will get 0. So if you multiply these two, you will get 1. This is, these two multiplication will get you 1. And what you need to do, you have to add this answer, this particular x dot y plus z, this one. So what you will get now? 0 plus 0. So you have to add these two. You have to add these two. So it will be 0. And then if you add these two, it will be 1. If you add these two, it will be 0. If you add these two, it will be 1. Again, it is 0. It is 1. So this is 1. And 1 plus 1 also 1. So this is the final truth table. This answer is the final answer for the exact output. So the output will perform if 0, 0, 0 has been given, the output will be 0. If 0, 0, 1 is given, because there are 3 different variables, so you can give 8 number of combinations. So if 0, 0, 1 is given, the output becomes 1. Likewise, if 1, 1, 0 has been given, the output will be 1. So this is the meaning of a truth table. This is the meaning of a truth table. And if you see this one, what is the input has been given and what is the performance of the particular Boolean expression or Boolean algebra expression has been given here. The truth table will give you the idea. That's all. That is the meaning of a truth table. You have to understand, right? And the next concept, it is tautology and fallacy. See, it is very important. While simplifying the Boolean expressions, you have to understand what is tautology and what is the fallacy concepts, right? So, what is tautology? If the output of a Boolean expression is always true or 1 is called tautology. If the output, whatever the input you give, the output always becomes 1. And those kind of functions or Boolean expressions are called as tautology functions. And also, if the output of the Boolean expressions is always false or 0, it is called as fallacy. So fallacy always fails, tautology always wins. So that is the actual meaning of tautology and fallacy. And what is the expression for tautology? First, I will go for the tautology expression. For example, see, this is the tautology expression. First, I will write down the expression for tautology. It is P plus P bar. That's all. This is the tautology expression. See, how many variables are there, there is only one variable. So if p is there, only one variable, right? Not p dash is not a different variable, same variable. So p, so it will be 0 and then this will be 1, and p bar, if you take p bar, then the complement will come, right? So this will be 1 and this will be 0. And if you want p plus p bar, if you want p plus p bar, then what is the answer you will get? If you add these two, what you will get? 1. And if you add these two, you will get also 1 here. So you try to understand whatever the input you are giving, p is the input, so you are giving 0 and then 1, and the function whatever we are getting here as p plus p bar is always 1, is always 1, right? So this function, that is p plus p bar, we generally call it as tautology function, always gives you 1, right? The next one, next one is a fallacy, right? Fallacy, for example, you take a expression like this, that is p dot p bar, p dot p bar. Say again, same thing, a single variable. So the inputs will be 0 and then 1. And if you take p bar, p bar is a complement, right? So this is 1 and this will be 0. And if you see this one, p plus p dot p bar. So if you do so, what you will get here? What you will get? So 0 dot, you have to multiply these two. So this will be 0. You have to multiply these two. This will be 0. And you see this function, this particular output. Always whatever the input you are giving at 0 and 1, the output will becomes always 0, always 0. So generally we call this function as fallacy, whatever the input. So if you see this one, you generally put 0, you don't need to do anything. P plus p bar, if you see any of if you see any expression, and if you find this p plus p dot p bar, then obviously you put 0. And if you see any p plus p bar, then you have to put it as 1. So that is the whole idea. See the next one, we will take some exercises to understand things well. See, what is the question they have given you? Evaluate the following Boolean expression using truth table. Just you have to write the truth table and you have to write what is the output of these two expressions. See, how many variables are there? X and Y, only two variables are there, right? So what you will get now, I will go for A here. So you will get X and then Y. So the inputs will be, so you write what are all the inputs that can be given here. Only two variables are there. See, only two variables. So obviously if it is two variables, 2 power n, it is 4 combinations. 4 number of combinations will be there. So it will be 0 0 and then 0 1 1 0 and then this will be 1 and 1. So you need this expression, right? So for that, what you do, first you find what is x dash, and you also need y dash, right? So you also need y dash, and you can see here you need this one separately. So you try to get this one separately, and then you need this one separately. So find this one separately, and then you need these two operations. So you have to write like this. So this is like plus and then x dash y. So I will just put a line here. This one separately you need, this one separately, and then these two separately. So this is the thing you have to find like this by using truth table. They have given you, see, these kind of expressions can be simplified by using the postulates, and there are so many laws are available, and also you can simplify by using Karnaugh map, and we are going to do those kind of things in the future classes anyhow. By truth table you have to understand, so that the meaning of truth table, you will get exactly the meaning of the truth table, right? So we will do that one right now. See, we have written this one. What is x dash? See, I have to put a line here too, so that you can understand. So you see here, what is this one? X dash. So the complement of this one, so this will be 1 and this will be 1. This becomes 0 and this becomes 0. That's all. That is x dash. And y dash, you have to do the complement of this thing. So this will be 1 and this will be 0 and this will be 1 and this will be now 0. and you have to, if you don't see anything here, you have to defaultly understand, and these two are now the multiplication dot operation, right? So you have to multiply these two, x dash and then y dash. So if you multiply these two, what you will get? This is 1. If there is 0, then it will be obviously 0. This will be also 0. And x dash y. So this one and multiplication of this one. Try to understand this, this one and multiplication of this one. So you see here, if you multiply these two, you will get 0. If you multiply these two, you will get 1. If you multiply these two, you will get 0. If you multiply these two, again you will get 0. So now we have found what is x dash y dash and then x dash y. And you have to add these two now. Addition point, right? So you have to put a plus operator, addition. So if you add these two, you will get 1. If you add these two, you will get 1. And if you add these two, 0, 0. See, try to understand. The expression x dash y dash plus x dash y, the output will be what? It will be 1, 1, 0, 0. And if you give 0, 0, this particular expression will give you 1. And if you give 0, 1 for x and y, the output will be 1. And if you give 1, 0 for this expression, then the expression will give you 0, and 1, 1, this expression will give you 0. So that is the exact meaning. That is the exact meaning. Try to understand, right? So now we will take this one, this expression. See here, I have just taken this expression. So you see here, x, y, z, there are 3 variables. If there are 3 variables, so 2 power 3 will give you 8 number of combinations. So you have to take x separately, y separately, and then z. Then you have to write the equation. So I have already told you the shortcut. So 0, 0, 0, 0, 4 zeros, 4 ones. So this is 0, 0, 1, 1, again 0, 0, 1, 1. And this will be 0, 1, 0, 1, 0, 1, 0, 1. Right? So this is the thing. And what you have to do, so you have to write the expression. First, what you do, you just write the x dash, because what are all the complement functions you need, first you do that. First you do that, right? So you need x dash as well as y dash. So what you do here, you put x dash and then you put y dash, and you see you need this x dash multiplied by yz. So separately you go for yz, yz, yz. Y can be multiplied with z, and you can get this 3 now, x dash yz. So this is a separate dot. You can multiply these two now. These two. Try to understand me very clearly. And you need this x y dash, x y dash. So now you can add these two. So finally what you can do, you can add these two, that is x y dash plus x y dash, right? So you have to split your truth table like this, right? I will explain you again. See, first you get the complements. If you need complements, then you do this one. I have not gone for z dash, because why? I don't need z dash here. I don't need z dash, that is why I have not gone for that. And you need this multiplication. So y z, and you if you do so, you will get these two values now, and you can put a AND operator so that you will get this one, and you need this one separately, right? So already you have x here, and already you have y dash here. So x and then y dash you can multiply, you put here. So now if you add these two expressions, that means you put a OR operator to get the values, right? So I will put the tabulation. So you see here, I have just done this. So x dash, what you will get for x dash, the opposite of this one. So it will be 1, 1, 1, 1, 0, 0, 0, and then this will be 0. And y dash, it will be opposite to this one. So it will be 1, 1, 0, 0, 1, 1, 0, 0. Just opposite this one, complement. And you have to multiply y z. You have to multiply these two. So if you multiply these two, it will be 0, it will be 0, again it will be 0. This is 1, right? Multiplication of these two. And if you multiply these two, 0, multiply these two, 0, 0, and then if you multiply these two, it will be 1. And what you need to do, you have to put a OR operation here. This is like an OR, sorry, not OR operation, AND operator. So if you have to multiply these two now, these two. So 1, 0, it will be 0. 1, 0, again 0. 1, 0, again it will be 0. 1, 1, it will be 1. and then 0 0 it will be 0, 0 0 it will be 0, 0 0 it will be 0, 0 1 it will be again 0. And you see you have to multiply x and then y bar, y dash, x and then y dash, this one and then this one. Multiply these two, 0 1 you will get 0, 0 1 you will get 0, 0 1 again you will get 0, sorry 0 1 0 1 0 0 and then again 0 0 you will get 0 for 4 0 because everything is 0, then obviously it will be 0, and then 1 and then this is 0. Oh, I am this value, right? So this is 1 and then this is 1, multiplication it will be 1, 1 multiplication of 1 it will be 1, 1 0, these two are 0, so obviously the value will be 0 0. So now we have got everything, so what you need to do, this is an OR operator, so you have to add these two, you will get 0, add these two you will get 0, add these two you will get 0, this will be 1, this will be 1, this will be 1, this will be 1, and these two 0, these two 0 and then 0. See this one right now. So this is the final answer. So the expression of this one, x bar y z plus x y dash, will give you this one. If you give 0 0 0, the value will be 0, and if you give 0 1 1, then the output will be 1. So we have just made the values here. We have just made the values right there. So this is how we need to write the truth table, and truth table will tell you what is the input and what is the output of a particular Boolean expression, right? So the next one, see the question, verify that p plus pq the whole bar is a tautology. What is tautology? Whatever the input you will give, the output should become 1, right? That is the tautology. So how many variables are there? Only 2 variables, right? This is p and then q you have. So if you go for p and then q, so I will write it down, this is p and then this is q. So how many combinations? 0 0 0 1 1 0 1 1, right? That is the value, and you need to write p plus q the whole bar, and what you need here, see p is directly there, no problem. So p dot q you need to go for this one, and then p q the whole bar, and then what you do, whole bar means what, you just complement this one, and then the next value will be p plus this value, pq the whole bar, right? I will tabulate it, so I will go fastly now. Pq, you have to multiply these two, 0, multiply these two, 0, multiply these two, you will get 0, multiply these two, what you will get, 1 now. So p dot q the whole bar, so what you do, you need to complement this one, so it will be 1 1 1 and then this becomes 0, and p plus q bar, right? So this value has to be added with this one, so 0 plus 1, 0 plus 1, 0 plus 1 you will get 1, 0 plus 1 you will get 1, 1 plus 1 you will get 1, 1 plus 0 again you will get 1. See here the answer 1 1 1 1, whatever the input you give, 0 0 0 1 1 0 1 1, whatever the input you give, the output becomes here 1. That's all. This is the tautology, and we have verified with the truth table. And this one you just do by yourself. I will explain you in the next class. This is a homework problem. Homework. You do this one. I will explain you in the next class. See what are all the topics we have seen in this particular lecture. See, we have started with a new topic, Boolean algebra, and we have seen what is Boolean algebra, and there are 3 different operators. We have seen what is AND operator, OR operator, and NOT operators, and then we have gone for what is the importance of truth table, and we have just verified an expression with a truth table, what truth table will give you, and then we have gone for fallacy and tautology, and then we have just gone for the exercise problems, and we have taken 2 3 problems to verify it with the truth table. We will see in next class.